Hey, good morning, everybody. This is Mr. Ainsworth here at Great Oak High School, and we're going to get into 7.6 Part 2 and do applications here on our identities. And in the previous video, the main derivation video here, I went over and derived using all kinds of identities, the co-function identities and the identities for even and odd, functions for sine and cosine to derive all this. And so if you haven't seen that, well, you should probably go through it. In this video here, in Part 2, we're going to kind of apply what we learned and deal with some real problems. So the first one here, though, in the check for understanding, it says for alpha and beta in the first quadrant, because again, this is a unit circle here in quadrant 1. So first quadrant, is sine of alpha plus beta greater than, less than, or equal to sine alpha plus beta? Well, let's find out. Okay, so again, I'm going to use some triangles here. So let's all focus in on a particular triangle here. So let's take a look at triangle ALC. You'll see why in a minute. So let's grab a color here and highlight triangle ALC. So which one is this one? A to L. There we go. There's triangle ALC. Now in there, guess what? Alpha's in there, and that's why I chose it. Alpha's inside there, and I need expressions for sine alpha and sine beta, and an expression for sine alpha plus beta. So let's make it happen. All right. So in this triangle, sine alpha is equal to, so sine of alpha is equal to the opposite side, which is CL. All right, CL here, divided by the hypotenuse, which is from A to C. And guess what? AC is a radius. And if you're on the unit circle here, this is a unit circle, you can tell because AD is 1. So it's a unit circle. And AC is also a radius. All right, so AC is length 1 as well. So it's CL divided by 1 or CL. Okay. Now I need to get an expression for beta, and beta is in a different triangle. So I'm going to switch to AGD. You saw this in my first video, part 1. So let's switch triangles here to, oh, it's getting late. So let me draw better here. Okay, there we go. Sorry. Okay, so that triangle right there is ADG. That's the one in blue. So let's take a look at this one. So triangle, whoa. Triangle ADG. So cosine here, or excuse me, sine. So sine beta, what is that? Well, again, it's opposite divided by hypotenuse, right? So opposite of beta is DG. You saw me do stuff like this in our first video, divided by 1, which is DG. Okay, so now I need to switch triangles again, right? So let's take a look at alpha plus beta, and alpha plus beta is in our main skinny triangle. So let's take a look at the green one now. Okay, so here we go. So this one here. Okay, so AED. Okay, so now my next triangle. So triangle AED, the main one there, and I want cosine of alpha plus beta. I'm sorry, not cosine, sine of alpha plus beta, which I did in my first video as well. And that right there is opposite of that angle is from D to E, right? So from D to E. But as you guys know from the first video here, the distance from D to E is equal to DE, or D to F, plus F to E. So this is equal to D to F plus F to E, using the segment addition postulate. So I know that is true as well. Okay, so now what does that mean? So let's compare these two here. So notice in the triangle though, let's go back up to my first statement here. In triangle ALC, sine alpha is equal to CL. Now CL, let's take a look at it. CL, how is that compared, this distance right here, to FE? Well, in the figure here, it's longer. Okay, so it's longer than FE, so I can say it's greater than FE. Okay, now I want to compare DG to to DF. Okay, so where's DG? So DG is a hypotenuse here on this triangle right here. And how is it compared to DF? Now, DF is a leg. This is a hypotenuse. Okay, and everybody should know that the hypotenuse is greater than the leg on all right triangles. So DG is greater than DF. So it's greater than DF. I know that. Okay, so now what I'm going to do is I'm going to take these equations right here. They're called inequalities right here, and I'm going to add them together. Okay, so just get a little creative here. So on the left side, I'm going to add CL and DG, and that's going to be greater than the sum of the other two, FE plus DF, right? And then what is that? What's CL? Well, CL is sine alpha. And then DG, what's that? Well, it's sine beta. And that's got to be greater than the FE plus DF. But what's that? Well, it's DE, right? Right? But what's DE? Well, it's sine of alpha plus beta. All right. So here I said sine alpha, or I ended up with sine alpha plus sine beta is greater than sine of alpha plus beta. All right. So it's the question says, is it greater than, less than, or equal to the sine of alpha plus beta? So I'm going to reverse it. So here now the sine of alpha plus beta is now less than the sum of sine alpha plus sine beta. All right, it's less than. Okay, less than. There we go. And I just answered that question. And again, that takes some effort, guys. Okay, it takes a little creativity. It takes some geometry. It takes a little trig because you had to use your ratios for sine of alpha, sine of beta, and the sine of alpha plus beta. That was a good problem right there. Okay, that was pretty cool. All right, so now there's a little summary section here. This is obviously a summary. Okay, and there's one other identity that I need to throw in here. And I'm going to take this one here, our main identity, and I'm going to develop what's called a double angle identity for sine, because it comes up. It's in the lesson down here somewhere. You have to solve, like number 4, you have to solve sine of 2x minus sine x equals 0. Well, you need a double angle identity, and it's easy to get. It almost comes free. So double angle identity for sine. We don't need for cosine at the moment. If we do, we'll get that later, okay? All right, so it's easy. You just let alpha, or substitute alpha for beta, right? So let beta equal to alpha, basically. So sub in alpha in for beta, and then see what happens. So here we go. So I know that the sine of alpha, okay, I'm just going to write the identity up here. So the sine of alpha plus beta, I'm just going to repeat the expansion, is the sine of alpha times the cosine of beta plus cosine alpha times a sine of beta. We know that, okay? But if I substitute an alpha in here, I get the sine of alpha plus alpha right here. Again, I'm just making a very simple substitution. Wherever I see beta, I'm going to substitute in alpha. I just did. Okay, so what do I get? I get sine of alpha times cosine of alpha. There's my substitution again. Plus cosine of alpha times the sine of alpha. So let me highlight my substitutions. Everywhere I saw beta, I put in alpha. Why? Well, alpha plus alpha is 2 alpha, right? So the sine of 2 alpha is the same thing as sine of 2 theta. It's just another variable. And there's your double angle identity. And now notice that these two expressions, they're the same. And you've got 2 of them. So this is simply equal to 2 times sine alpha times cosine alpha. And there's your double angle identity for sine. We call it a double angle identity because it's 2 alpha, not 1 alpha. Okay, so that 2 in there is where the name double comes from. Okay, 2 alpha is a double angle. All right, so there's your double angle formula there. Let's add that to the list. This is equation 5. Okay, we're going to extend that from first lesson here. And now it's time to apply your expansion formulas, your sum formulas for sine and cosine. So here we go. So find an exact value for 75 degrees. We want to rewrite 75 degrees as a sum or a difference of two known angles on the unit circle. So can you think of 75 as a sum or difference of two angles? Do you know two angles on the unit circle, which basically add up to 75 or subtract to 75? And guess what? There's more than one answer. All right. And so if you're thinking 30 and 45, you got it. Okay. So here we know that 30 degrees plus 45 degrees is equal to 75 degrees. So the first angle is alpha and the next one's beta. So here we go. Let's expand it. Excuse me. So I'm going to take the first, my main identity up there at the top of the screen, and I'm going to substitute 30 degrees in for alpha and 45 for beta. So here we go. So 30 sine of 30 degrees plus 45 degrees is equal to the sine of the first angle, 30 degrees, times the cosine of the second angle, 45 degrees, plus cosine of the first times sine of the second. And then all you do is simplify. Okay, and then you kick in, either the unit circle or your special right triangles. So I'm going to write down the special right triangle over here off to the side like I always do. All right, now we know the sine of 30 degrees is a half. Sine of 45 degrees, well, we need a different triangle for that. So 45, 45, 90 is 1, 1, rad 2. So the sine of 45 degrees is rad 2 over 2. Plus cosine of 30 degrees, which is rad 3 over 2. Times the sine of 45 degrees, which is root 2 over 2. So my first fraction is root 2 over 4. Second fraction is root 6 over 4. And so this is actually equal to root 2 plus root 6, all divided by 4. And there we go. And that's when they say exact value here, they mean no calculator, okay? All right, no calculator, no TI-84. No TI-84. Okay, use the calculator between your ears. Okay, and there you go. All right, next one, find the exact value of cosine of 225. All right, so here we go. So we need two angles that add up to 255 or subtract to 255. You can do a sum or a difference. So, what alpha plus beta equals 225, or excuse me, 255. So 255. So can we think of two angles on the unit circle that add up to 255? Well, if this one's 210 plus 45, does that work? Oh, that works. Are these on the unit circle though? And the answer is yes, they're on the unit circle. So that's a good thing. So one way to do that is do this right here. There are many possible combinations here. So many possible sums here. So keep in mind there's more than one way to do this. Okay? If I can write right now. Okay, so all right, so be creative. Now here we go. So the cosine of my two angles, right? So 210 plus 45. That's equal to, then now I need the cosine expansion, which, is it up here? Yes, it is. It's at the top of the screen. Okay, so look at the top of the screen. So now, again, this is alpha and this is beta. So it goes cosine, cosine, change sign, sine, sine. That's how I remember it. So the cosine of the first angle, 210 degrees, times the cosine of the second angle, change the sign, and then the sine of the first angle times the sine of the second angle. Okay? So now that we have that, we expanded it. Okay, you expand first. All right, that's step one. Step two, you simplify. Okay? Step two, you simplify. So here we go. And then again, we need our triangles now. So let's bring the 30, 60, 90 over here, just so you guys can visualize. Okay, this is a skill that you need to just do, or you just have the unit circle memorized. Do whatever it takes, right? Now 210 is quadrant 3 and cosine's negative there. So, and we know the cosine of 30 degrees is rad 3 over 2, but this is negative, so it's negative rad 3 over 2 times rad 2 over 2 times now minus 210, sine of 210. Now sine's negative there too, but the sine of 30 degrees is 1/2. So this right here is negative 1/2 times rad 2 over 2. And notice that I put the negative 1/2 in parentheses here because we've got a double negative going on, and the very common mistake people make is that they forget one of the negatives and obviously get their answer wrong. So you got to be careful. So here I got a negative root 6 divided by 4 plus rad 2 divided by 4. And so this you can write it as negative root 6 plus root 2 all divided by 4. But most people write it as root 2 minus root 6 all divided by 4. Okay, and there you go. There's a little application of your sum and difference formula for sine and cosine. And all you guys need to do is get some more practice. So you need to continue the check for understanding here. So continue this. Check for understanding. And then obviously check with instructor's notes when you're done. So check with instructor's notes in Canvas. Okay, people make a mistake of not doing that and they don't know they're making mistakes, which is not good. So don't be one of those people that is, not wise. Okay, be a good student. Check your work with mine or another classmate if you're doing it together, and then check it with mine, and then make sure you're doing a good job. Okay, so there you go. There's part 2. And then the rest, if you need help on the rest of this, well, you better just come and see me before school, right? Because I can't run a video for everything, okay? So you got to work hard. Come and get tutoring if you need to on before school every day of the week. I'm one of the very few teachers that offers tutoring before school every day, and pretty much even at lunch too and after school. So come and get help if you need to. Work your butt off, and I will see you in my next video, or hopefully I'll see you in class. Take care. Bye-bye.